Hi, this is from Dr. B. Vijay Kumar, HOD of Physics, SNS College of Engineering. Today we discuss the topic of coordination number and packing factor for simple cubic and body center cubic. This is under the crystal physics unit by the course name of Physics for Mechanical Engineers. This is we have taken from second semester of first year students. So, how do you find the coordination number of a unit cell? Then how do you calculate that packing factor of a crystal system? Because the last video we discussed from the characteristics of unit cell. The characteristics of unit cell is a four. The one is number of atom per unit cell. Second one, coordination number. Third one, atomic radius. Fourth one, atomic packing factor. So this four is a characteristics of unit cell. So this two we have asked from the question to starting of this PPT. Then importance parameter in a crystal system structure, the number of atom per unit cell. The one side we recap the term. The total number of atoms shared by unit cell is known as number of atom per unit cell. It can be determined the arrangement of atom inside the unit cell in a lattice manner. This is known as a number of atom per unit cell. The next one is an atomic radius. The atom is occupied in a lattice within a periodic formation. So the radius of the atom we have find it for this parameter. The atomic radius is defined as a half of the distance between any two nearest neighbor atom which have direct contact with each other. The next one is a coordination number. The nearby the atom to be shared from the surrounding of the atom to connected, that is a coordination. So every atom in a crystal structure is surrounded by other atoms. The term coordination number is defined as the number of nearest neighbor directly surrounded by an atom. When the coordination number is large, the structure is closely packed. The packing density or atomic packing factor in terms of APF, it is defined the ratio of volume of all the atom in the unit cell to the volume of the unit cell. The coordination number for simple cubic structure, this is simple cubic structure, atom's position. The shaded atom, it becomes in a corner atom. Then another one atom is formed in a that phase atom. So the simple cubic structure share 8 atom, one in each corner. Each atom in the corner is shared by 8 adjacent unit cells. Hence 1 by 8 part of an atom is present in every corner of the cube. There are 8 corners, therefore we get the total number of atom in unit cell is 1 by 8 into 8 equal to 1 atom. The atomic radius for simple cubic structure is R equal to A by 2. Then APF of C by 2. The finally we get after the calculation in right side I mentioned from this all the details. The APF formula is volume of atom in unit cell by volume of unit cell. So the atom is look like in a spherical formation. So we used in volume of sphere is 4 by 3 pi r cube. Already we know that the radius, atomic radius, substitute the data from there, we get in final answer of APF. So simple cubic, it 52 percentage of the space in the unit cell is occupied and remaining 48 is unoccupied. Therefore, the stability of the crystal forming simple cubic structure is less. The example is polonium. The next one is in a body center structure, that means BCC. The total number of unit cell 1 by 8 into 8 is told to 1, that is a corner, and body is full is 1 with not share. So the final, the total number of atom per unit cell in BCC equal to 2. Then assignment, how we change the atomic packing factor, difference between simple cubic crystal and body center cubic crystal. The final answer we get from the atomic radius R equal to A root 3 by 4. Then APF, finally we get that the same formula we applied in that. Final answer we get 0.68 percentage of atom is occupied from in a unit cell. The other 32 is not unoccupied. So this is all the reference. I prepared the PPT of the coordination number, atomic packing factor of simple cubic and APF. Thank you very much. We discussed in another one topic in another one video. Thank you.